All right, this is going to be to review longitudes. Let's take a look at the longitude questions here. Okay, the map below shows four major time zones of the United States. The dashed lines represents meridians of longitude. The locations of New York City and Denver are shown. And it says, what time is it in New York City when it's noon in Denver? So what we talked about with time zones is this, that this whole area right here would be noon 12. And if you go to a time zone to your west, time will become less. If you go to the east, it will decrease. So if it's 12 here, then in this time zone, it would be 1. This time, going to the east, time is going to increase. And over here, in this time zone, it would be 2 o'clock. And now, since New York is in this time zone, we have our answer. Letter B would be the correct answer. The above diagram below represents, or the diagram below represents a view of Earth from above the North Pole. Points A and B represent locations on Earth's surface. So when we look at this, we're actually looking at a different way of looking at the Earth. We're looking down at the Earth from the North Pole. We have the sun's rays coming in here, the daytime side, the nighttime side. These spokes here are actually longitude spokes, and these circles right here are actually latitude rings, okay, because we're looking down from the north. So locations A and B would be on the same longitude line. Because they have the same longitude, they'd have the same local time. Okay. Number 3, the diagram below shows latitude measurements every 10 degrees and longitude measurements every 15. What is the latitude and longitude of point X? Well, first of all, I know point X up here is in the northern hemisphere, and because of that, I can get rid of A and C right away. I also know it's in the western hemisphere too, because it's to the left of the prime meridian. That means that letter B is correct. Now, if I go along with what they were saying angularly, if this is going up by tens, it should be 0, 10, 20, 30, 40, 50. That works out. And if this is going by 45 or 15s, this would be 0, 15, 30, 30, 45. And that works out. So letter B is the best choice on that. Let's go to number 4. Okay, number 4 gives a whole bunch of information. Let's just read what it says down here. Which two locations have the same solar time? Locations that have the same solar time would have measured with their using the sun when noon was, and they'd find they were on the same longitude. So B and D would have the same solar time. They're on the same longitude. As a ship crosses the prime meridian, an observer on the ship measures the altitude of Polaris to be 60. What's the ship's location? Well, since they measure the altitude to be 60, they've got to be at 60 degrees north latitude. And since they just crossed the prime meridian, their longitude would be 0. So it would be letter B for this one. When the time of day of a certain ship at sea is 12 noon, the time of day at the prime meridian is 5. What's the ship's longitude? Well, the amount of time difference between the two ships between 12 and 5 is 5 hours. And if I take 5 times 15, I'm going to get 75. So I know that the longitude is 5 times 15, 75. Is the ship to the east or the west? Well, the ship's time is 12 noon, which is earlier than 5 p.m. at the prime meridian. So time is less, so the final answer would be 75 west. Since Denver's longitude is 105 degrees west and Utica's longitude is 75 degrees west, sunrise in Denver occurs. Well, they're not in the same time zone. They're 30 degrees off. If you notice, 105 minus 75 is 30. So 30 divided by 15 gives me a 2-hour difference. Now, Denver's time is actually earlier than Utica. Utica would get sunrise first, and then Denver would get the sunrise 2 hours later, since it's 2 hours earlier in Denver. Number 8, the imaginary, the diagram below represents 4 systems of imaginary lines that could be used to locate positions on the planet, and which system is most similar to the latitude-longitude system. And I would go letter A, where I have parallel latitude lines and I have longitude lines that meet at the poles. Okay, in this diagram, it says the diagram shows 3 locations labeled X, A, X, and B, and which table correctly indicates the solar times at A and B when it's 12 noon at X. So if it's 12 noon at X, B is over here at 60. Is it 60? No, excuse me, 45. So 0 to 45, that's 45 degree difference. divided by 15 gives me a 3-hour difference. So B is 3 hours later, which makes that 3 p.m. And A, let's see, that's 1 hour, 2, 3, 4, 5, 6 hours earlier, which if this is 12 noon, makes this 6 a.m. I'm going to have to go with choice B for this, that A is 6 a.m. and B is 3 p.m. Which two observers would be experiencing the same apparent time? That would be B and E because they're both located on the same latitude line. Excuse me, longitude line. Okay, if it's solar noon at X, at which location will solar noon occur next? So all these places over here are ahead of time. They've already had their solar noon. They're ahead. The next solar noon would be at B, which is behind time right now, but eventually it will reach the point where it's solar noon. So it's earlier at B, they're going to be the next solar noon. Cities on the same meridian always have the same solar time. A person knows the solar time of the prime meridian, local solar time, they can tell the longitude they're located at.
How you doing, Rob? Okay?
Good, I'm making a video right now, but all is well. The basis for the time difference for adjoining the time zones is that the Earth is turning at 15 degrees per hour. If the time in Buffalo is 5 a.m., what time would it be in San Francisco? So if it's 5 a.m. here, then when we go here, it would be earlier. It would be before over here. Whoops. It would be 3. 3. And out here in California, it would be 2. Because when I go to the west, my time is less. And it would be 2 a.m. And the last question we have here is what is the approximate latitude and longitude of A? And for A, if we look over here, A is about 15 degrees north. And looking at the numbers we have here, there's 120. Let's say that's 135, 150, 165. So it's got to be somewhere around 160 west. Put it all together, 15 degrees north, 160 west gives us letter D as our answer for that. All right, I hope this was a valuable video for you. Thank you so much.